So now that we know how to actually place these electrons around our nucleus, let's take a look at some actual elements from the periodic table. So let's start with hydrogen. It's the very top left, atomic number is 1, so that means it has 1 proton, and for us, that means it also has 1 electron. So I've placed that electron on our atom model here. And from here, we can figure out how many valence electrons hydrogen has. Now, a valence electron is any electron on the outermost energy level. Here, it's only taking up 1 energy level or shell, and there's only 1 electron there. So it only has 1 valence electron. Let's go to the next one down in the same column. In column 1, the one directly below hydrogen is lithium. Lithium has an atomic number of 3, so 3 protons, so likewise 3 electrons. I've put 3 here. I took up the first energy level with the first 2. So 1, 2, then I move to the next one, and I put 3. So the outermost shell for lithium is this second one. How many electrons are there? Well, I only see 1. So lithium also has 1 valence electron. Let's move down one more. Right below lithium, we have sodium. Sodium has an atomic number of 11, so it has 11 protons and also 11 electrons. When I put the 11 electrons here, I take up the first energy level. I also take up the second, and I move to the third. So my outermost shell or energy level is this third one out here. How many electrons are on that outermost shell? Well, I only see 1. So sodium also has only 1 valence electron. And so we figure out a nice pattern here. If I went down to potassium, rubidium, cesium, francium, anything in that first row of the periodic table, all of these elements would have 1 valence electron. That's what's common about these in the same group. The same thing can be done for the second group. If I move the electrons and put them on the atom for beryllium, magnesium, calcium, strontium, anything in group 2, those would actually end up with 2 valence electrons. And so on and so on. We skip this middle one, or this middle section, from 3 to 12 because those don't really follow the nice rules that we want to apply to this. Those would be done in chemistry. So we skip to row 13. If I made the atomic structure for boron, let's go ahead and do that. Boron has a atomic number of 5, so it has 5 protons and 5 electrons. So 1, 2, 3, doesn't have to be perfect, 4, 5. So it's got 5 electrons. This second shell is its outermost shell. How many are there? I see 3 valence electrons, and this was for boron. So anything in the same column as boron, aluminum, keep going down, has 3 valence electrons. Go one row over. Notice our pattern. Column 1 was 1 valence electron. Column 2 was 2. 13 has 3. And then as we keep going up in these columns, we just keep adding 1 valence electron each time. So group 14 would have 4. Group 15 would have 5. 16 has 6. 17, 7. And 18 would have 8. Now the thing about group 18 is if I have 8 valence electrons, notice on every shell except the first one has 8 spots. So this last group will have a full outer shell. So if it goes out to the third energy level, that energy level is going to have all 8 spots taken up by electrons. That is going to be something helpful to write on your periodic table if you have it printed, or write somewhere that you can go ahead and write above this column, this has 1 valence electron. Above column 2, write 2 valence electrons, and so on all the way up to group 18.